Hello, in this second part of my Tesla Coil series I'm going to equip my Tesla Coil with some electronics. Mainly I'm building a high power half bridge which connects to the primary. The driver board to control the half bridge and run the coil in resonance frequency is also part of this video. Core of the half bridge are two MOSFETs, which I mounted on an old CPU heatsink to cool them properly. Because there is a contact on the back of the MOSFETs, I had to insulate them electrically to the heatsink by placing a special thermal conductive insulation between them. The chips are fixed with a small metal bracket and a screw. I also added thermal paste to improve the cooling. To supply constant direct voltage to the system, I used two electrolytic capacitors with 220 microfarads each, which smooth the rectified alternating current. They also provide a buffer for the pulsating high current draw of the primary coil. Next, I added two capacitors, which create a voltage divider to allow current to flow in both directions through the primary coil. So one of the primary ends is connected to both MOSFETs, which switch between the positive and negative terminals of the buffer capacitors. The other end is connected to the voltage divider. All high current connections were made from two lines of 1.5 square mm solid copper wire and a good amount of solder to decrease the losses and unnecessary heat production. I had to make everything compact, but this design is not perfect because when a MOSFET breaks, what isn't very unlikely, I have to take the whole system apart to replace it. I further added two diodes and the rectifier, and then the high power part was finished. The driver circuit was created on a prototyping PCB. I'm now jumping over the soldering process and just showed the finished board. The main components are two MOSFET driver ICs, a Schmitt trigger to create clear signals for the driver ICs, a gate drive transformer to bring the switching signal to different potentials, a DC blocking capacitor and an optocoupler to decouple the interrupter from the rest of the system. The next step was to install everything in the housing, beginning with a very important part, a fuse holder, followed by a main power switch. Ground was connected to the housing and the power lines were connected to the fuse and the switch. I added a 12 volt 3 ampere switching power supply and connected it. The power element also found its place in the housing and was fixed by screws through threaded holes in the cooling fan. I also wanted to add a relay to be able to remotely turn off the power circuit. Unfortunately, one of its leads broke, but I was able to repair it, and so I also can use this safety feature. Further, a 5-pin socket was added to connect the remote control later. Lastly, I installed the control circuit and wired everything. In the next video, I'm building the last piece, an Arduino controlled interrupter/remote control for the Tesla coil. So stay tuned and don't forget to like and subscribe. Bye!